Have you ever looked at a clock and wondered, who decides what time it is? Your phone, the government, some ancient sundial in a museum? I'm Professor Sagewell, and today on The Curious Professors, we're diving into how people around the world agree on something as strange as a single second. Here's why it matters. On July 9th, 2025, Earth spun slightly faster than usual. The entire day was shorter, by 1.3 milliseconds. That's faster than a blink. But in science and technology, tiny time changes can cause big problems for satellites, clocks, and systems all over the planet. Even more surprising, this wasn't a one-time event. Scientists expect 2 more micro-short days on July 22nd and August 5th. So what's happening? Let's start with the basics. Earth spins once every 24 hours. But that speed isn't perfectly consistent. Our rotation changes slightly because of gravity, ocean tides, atmospheric pressure, and the moon's position. Even melting glaciers can make a difference. Some years Earth spins a little slower. This year it's spinning a little faster. That makes some days a fraction of a second short, but most clocks don't notice. Why? Because we use something called atomic time, based on the steady vibration of cesium atoms. Atomic clocks are incredibly precise. They never speed up or slow down, so when Earth's spin changes, atomic time and Earth time begin to drift apart. To keep things in sync, a special group of scientists watches Earth's rotation. They're called the IERS, the International Earth Rotation and Reference Systems Service. Their job is to compare Earth time with atomic time. If the two drift too far apart, they recommend a fix, a leap second. A leap second adds exactly 1 second to the world's clocks. It's rare, and usually added on December 31st or June 30th. Most leap seconds are added. But scientists now think we may need to subtract one. That's called a negative leap second. It's never happened before. Why would we do that? Because Earth's rotation is speeding up. And if it keeps going, we may need to skip a second by 2029. Instead of adding a second at midnight, we jump forward, skipping 1 second entirely. The second would simply vanish from the clock. You might think 1 second doesn't matter, but it really does. Especially for technology like GPS, which depends on exact timing to work. GPS satellites use time to measure distance. If their clocks are off by even a millisecond, they might think you're in the wrong place, by several miles. And it's not just GPS. The internet, airplanes, banking systems, and even power grids all depend on perfectly synced time. Imagine if 2 banks processed a payment at slightly different times. 1 second could change the order and cause major financial errors. So, timekeeping is about more than minutes. It's about how people and systems around the world stay in sync, no matter how fast Earth is spinning. In 2022, world leaders and scientists voted to stop using leap seconds after 2035. They'll let atomic time drift naturally instead of adding sudden adjustments. That decision came from international agreement, just like time zones and calendars. It shows how people work together to shape the systems we all depend on. So yes, while Earth spins under our feet, the people of Earth are making decisions about what time it really is. And those decisions are global. Every clock, calendar, and schedule you follow exists because people agreed to follow the same system. That's cooperation in action, and it happens across countries and continents. Quiz time. Let's see how much you remember from today's episode. Here's your first question. True or false? Leap seconds are only added, never subtracted. The answer is false. Most leap seconds are added, but we may need to subtract one in the future if Earth keeps spinning faster. Next question. What happens if GPS systems are off by just 1 millisecond? They could calculate your location incorrectly by several miles. That's how important precision is when satellites measure distance using time. Final question. Who monitors Earth's rotation and recommends leap seconds? The IERS, the International Earth Rotation and Reference System Service. They keep atomic time and Earth time aligned. Here's your discussion question. If you were in charge of keeping time for the whole world, how would you handle Earth's speeding rotation? Would you subtract a second, let time drift naturally, or invent a new system entirely? Thanks for joining me today on The Curious Professors. If you enjoyed this episode, be sure to subscribe so you never miss a moment, even the really short ones. Until next time, I'm Professor Sagewell, reminding you that even something as small as a second can teach us a lot about the world we share.